Hi, Millie. Can you hear me?
Yeah, I can hear you. So, yeah,
Okay. Hi,
yes.
Millie. So,
Hi.
hi everyone. And I think we can get started now. I will introduce a little bit about AI Lab and then about
Mm-hmm.
you, and then you can start. Okay.
Sure, sure. Thank you.
Okay. So hi everyone, and welcome to AI Lab webinar series. Before we start, I would like to remind that you should mute your audio when our speaker presents. And if you have any questions, you can type out on the chat box or raise your question in the Q&A session. And the talk today is called Toward Factuality in Information Access, Event-Centric Multimodal Knowledge Acquisition. And my name is Stuart, an admin officer at AI Lab, and I will be your host today. And to get started, I'm going to introduce a little bit about AI Lab. AI Lab founded by Dr. Nguyễn Xuân Phong, Chief AI Officer at FPT Software since September 2019, and it is dedicated to AI research and training activities. And we invite individuals who are knowledgeable or passionate about data science and machine learning to join our community. And you can find more about us on Workplace Group, and Long will share the link to the chat box. We'll share the group here. And you can also follow our webinar series on YouTube. And now for audience joining us today, please stay till the end of the webinar. We will have very special gift for two audience. One having the best question selected by Ms. Manling will receive 200 gold. It's equivalent to 200,000 Vietnam dong, and another 200 gold for a lucky audience. And right now, I would like to introduce Ms. Manling Lee, our speaker today. Good evening, Manly. Thank you very much for joining us. And so could you briefly introduce yourself?
Yeah, sure. So I'm very happy to be here. Basically, I will be a professor at Northwestern in for 2020, and I just deposited my thesis last week. So I'm officially graduated from UIUC last week, and I will be a postdoc at Stanford University for a gap year. So I think next year I will mainly work on the language plus embodied AI, trying to see whether we could make some like improvement on using the language to help understanding the vision world or physical world. My research direction is mainly about multimodal machine learning, and also we focus a lot on trying to use language to help understand the other modality data. And during this process, we want to discover the knowledge inside this different modalities, like the event knowledge and also some common pattern knowledge. And then we also want to use this kind of knowledge to improve factuality and to make sure the information, the understanding of the multimodal system is trustworthy. Thank you.
And presented in our seminar today is Anh Dũng. I think, do you want to say hi to Manling?
Hi, Mei-Ling. Thank you very much. Can you hear me?
Yeah. It's very nice to meet you again.
Yeah, thank you very much for accepting our invitation to join the AI lab at FPT Software today. And I think in the audience we have a broad range of audience. We have AI residents who aspire to become researcher and we pursue PhD programs later on. And then we also have a lot of AI practitioners, AI engineers, and AI enthusiasts in the audience. So we are really looking forward to hear your presentation. And for the audience, especially the residents, if you have questions regarding the research topics as well as the opportunities to study postgraduate program, maybe with Professor Manling. Feel free to ask her at the end, because it is one of the rare opportunities that you can actually hear from a rising star in the field of information retrieval and data mining. You can learn a lot from Professor Manling as well. Thank you very much, and we're looking forward to your talk.
Yeah, I really appreciate the opportunity. And also, I think my advisor, Professor Heng Ji, mentioned that we have really good students here. So I'm really excited if any students are interested in the opportunity at Northwestern. So I actually, so can you see my slide?
Yes.
Yeah, so
yes.
you can see it full screen, right?
Yes.
That's nice. Yeah, so so basically, I have like 2 to 5 PhD positions for 2024. So that's the application cycle is this winter, and then the starting date of the PhD will be next September. So I think if anyone will be interested in working with me, I really appreciate if you could drop me an email and talk about like what you want to work with me, and then we can also discuss more about the application, or if you have any questions related to application or just some generic question related to PhD studies or just the graduate college like master studies. I'm also happy to talk about it. Yeah. So is there any questions? So I didn't hear it clearly. Sorry.
No. You please go ahead. I think it's just people forget to turn off their mic.
Sure. Yeah, I'm very happy to be here, and I really appreciate the opportunity to do the talk here. So I'm working on the knowledge acquisition, and this knowledge acquisition is from multiple data modalities like images, videos, and also maybe speech and other potential data modalities. And when we're trying to discover this kind of knowledge, we focus on some high-level semantics like events, and this kind of knowledge can help us to improve factuality in information access. For example, nowadays we are surrounded by all kinds of multimodal information, like this kind of pandemic news include text data and also image data and video data and also data modalities, and they are from different data sources, and we basically rely on this kind of data to get to know about what is happening around the world. And this kind of multimodal data is very expressive, so we can discover rich information from different data modalities and can understand the knowledge of the real world. For example, if we look into this image, we will get some major message from it. So I'm wondering whether you could share some thoughts about like what do you feel or what major message you can get from this image. Please feel free to speak up or to put it in the chat. So like what is happening in the image. Yeah. So I think it's basically about anti-vaccination protest, and we can figure it out because we can recognize the visual patterns. So as human, we can recognize this pattern to the anti-vaccination because we can break it down to like small patterns. For example, for the vaccination, we can link this kind of pattern to the semantics of vaccination, and also the cross marks, we can link this kind of pattern to the semantics of negation. So basically, as human, we are able to understand the semantics in the vision side. And if you focus on the information that we can get from the vision side, it contains different levels. Firstly, we can discover the objects, and we can also try to recognize the interactions between these objects. So we can figure out their physical relationship, and also we can know like this woman is holding a banner. And if we map them to the language space, then these objects can be mapped to the entities, and relations and scene graphs can be mapped to the entity relation graphs. But these kind of existing tools are trying to discover this object-centric information. So it only focuses on the event-related objects and also the interactions between objects. But they are not really trying to figure out what is behind the scene. As a result, the state-of-art system can generate the caption like the woman is holding a sign here, but it didn't really focus on like why they are holding the sign and what is the motivation behind this kind of action, and also what is the major information of this scenario. As a result, we really want to discover the deep semantic understanding. So we define deep semantic understanding by discovering the knowledge that humans are actively talking about during daily communication. So this kind of knowledge is something important that we really want to know by presenting this kind of image. For example, here, if we present this image to audience, we basically want the audience to get to know there's a protest event. And after that, we want to figure out who are the participants. So we have the objects like the woman and the children. And we also have objects like the banners. And we also can get to know about the background, like there are grass and also there are sunshine. So we also want to figure out the semantic role relationships between these objects and this event node. As a result, we could try to build the connections for these objects. For example, here, the women, the children, they are protesters in this protest. And the instruments they used are these banners. So this kind of information can help us to get to know like there are only banners involved in the protest. So it's not a violent protest. And then we can predict like what will happen next. So this kind of information is very important to like extract to get to know what is happening. And then we define this task called event extraction on the multimodal data. So the input will contain different modalities like text, image, video, speech, and the output will be the structured knowledge. So this kind of structure can be a graph or can be a table as we just shown in the last example. And it will contain two parts. The first part is the event type, like the protest event, and the second part are the participants. So we want to know who are the participants, and we also want to know the semantic roles of these participants. Compared to the entity-centric understanding, this kind of understanding is more challenging. For example, the entity-centric understanding, we only focus on like two objects, and then we try to focus on the physical relationships between them. So it's kind of generic, and it's really about the surface information, like the woman is holding the banner. And for the event-centric understanding, it's more challenging because it involves multiple objects. And also, this kind of structure is complicated. So we have a semantic structure rather than just a triple. And this kind of structure really tries to describe the deep semantics behind the scene. As a result, my PhD research is moving from this entity-centric understanding to the event-centric understanding. So we basically want to not only understand the woman is holding the banner, but we also want to figure out like what is the entire scenario. So we can change this kind of information from this single simple caption to the structure that we presented, like this kind of graph structure, telling us that behind the holding action, the real motivation is a protest. And this protest is about anti-vaccination, and there are like parents, children involved in this kind of protest. And there are a lot of banners serving as the tools. So our goal is to move from entity-centric to event-centric. And by moving from this direction, we are able to moving towards to the deep semantic understanding. And here we want to better define what is deep semantic understanding. So previously, with our existing tools has did great work on understanding the concrete concepts. And these concepts are static, and also they focus on the perception ability to understand the vision data. But currently, if we want to move it to the deep semantic understanding, we definitely need to focus on some abstract concept understanding. For example, this kind of protest event is a scenario, and we need to understand how multiple objects are interacting with each other, and it's kind of abstract because it's hard to ground to a specific region in the image. And this kind of information is also dynamic because event information always changing along the timeline, and we need to track the event changing. By understanding this kind of abstract and dynamic information, finally, we want to move towards to the cognitive understanding ability. So we want to understand like what is the motivation behind the scene. And after the current event, what will happen later. And then we can help people to tell a story and help people to really understand what is happening and also maybe moving towards to the underlying intention understanding behind the data. This kind of ability is very important in the current era of large-scale pre-training. For example, we currently have very powerful large language model like ChatGPT and GPT-4, but they are kind of flat model architecture, and they are surface to surface. So basically, they take the text sequence in and then outputs the text sequence out. So they do not really trying to care about like whether the factual knowledge has been captured and whether the reasoning chain is correct. So to improve this kind of ability, we need to move from surface to the deep semantic understanding. And then we could really tackle the problem like for the factual knowledge understanding, we want to understand the complex situation. So this kind of situation is not just about a text sequence, but we want to incorporate the information from multimodal data. And then we want to understand how they are connected, so we could understand the complex situation by jointly infer from different modalities. And this will need us to understand the multimodal semantic structures. And for the second challenge, we want to track the dynamics along the timeline. And this kind of tracking will need us to have the ability about understanding the long horizon temporal dynamics. To tackle this kind of four challenges, we also try to propose some methods. And then next we will dive into the details about how this kind of challenges can be solved using the methods that we proposed. So for the first challenge, to understand the multimodal semantic structures, we basically try to answer the questions like what is happening and who are the participants and where and when, this kind of factual related knowledge. So in this image, we try to produce a structure like a graph or a table here. And from the image side, we could understand like the tools they used are the banners. And then from the text side, like from this caption, we could get some information that are not expressible from the image. For example, we could get the information related to time and also related to location. So from this example, we can figure out that this kind of multimodal semantic structure understanding will need us to not only figure out this is about the caption and the image alignment, but we want to understand how these small pieces of information are aligned. So we need to pass the information into a structure from both modalities and then try to see how these structures of two modalities are aligned. So this is a structure level alignment rather than just the alignment between image and captions. As a result, our solution is trying to do structure level transfer across different modalities. So we propose a clip event and other model trying to incorporate this kind of multimodal semantic understanding ability into the pre-training process. And for the second challenge, we want to understand the long horizon temporal dynamics. So this basically can help us to understand questions about why and what will happen next. For example, given this image, as human, we will naturally have this question like what will happen next to these children. And this kind of question cannot just be answered using that single image, we actually need to go back to the entire long context. So we get all the news articles, we sample news articles following the timeline, and here we get like 4 pieces of news articles. And then we concatenate these 4 news articles into GPT-4 and ask GPT-4 to generate the answer. So GPT-4 will generate the answer like it's unclear about what will happen to these children. And also it will produce some statements like it's important to notice that the vaccination generally is beneficial. So it actually has 2 drawbacks. The first thing is that it's not able to make some connections between this long context trying to figure out like what will happen next. And another thing is that the generated output is not really factual grounded. So sometimes it will generate some statements like it has this encouraging statement trying to say vaccination is generally beneficial, but it's not trying to ground it into any facts related to this news. To tackle these kind of challenges, we want to ground the prediction into facts that we discovered from these news articles. For example, we could firstly extract the factual knowledge. Like here, we can extract the vaccination from the second piece of news. And then we can also extract the symptom related to vaccination. And after that, from the third piece of news, we can extract like a mandate event. And after that, we can also extract there are protest events happening against this mandate policy. So from this news article, we are able to build this kind of event graph. And this kind of event graph actually are just telling about what are the facts mentioned in these news articles. And after that, we could do predictions, condition on these facts we extracted from news articles. So we could predict that maybe there will be exemption event. And then we also want to build the connections between this event node and the existing participants. So we can predict that the examination agents are the schools. And we can also do alternative prediction because there might be potential outcomes from like different angles. So we could also predict there might be online teaching event, and we can also predict the participants related to online teaching. And also there might be suspended event and also maybe homeschooling event. So here we want to build the event knowledge graph that contain not only just the entity nodes, but also contain the event node. And the edges will be reached to adding like temporal edges and also participant edges to describe the semantics between events and entities. So this kind of event knowledge graph is different from traditional entity-centric knowledge graph. So we have new kinds of nodes, and also this kind of graph will show the temporal evolution about the events. As a result, along this timeline, we try to check the historical event graphs and try to induce the schema graph to describe the common pattern about event evolution. And then we'll use this kind of common pattern to help prediction of the future events. As a third research direction, we want to use these extracted facts to help the generation to be more truthful. For example, we could use these facts to do timeline summarization. And we also have a lot of demo and application about like COVID-19 claim detection and multimedia news question answering and meeting summarization and also event heat map building. For example, if here is the automatic demo that we built based on the extraction techniques and also trying to do the summarization based on these extracted facts. So this demo, we call it Smart Book because the input will be the thousands of news articles. And this scenario is the Ukraine crisis scenario this last year. So we collected the news data every 2 weeks. And then we asked the model to extract all the facts from these news articles. And then we generate the questions to describe these major events. And for these questions, we also discover the claims that associated with these questions. So this demo is also the online demo. And if you are interested in it, you are welcome to play with this demo. using the QR code here. And we also show another interface that we are able to order the claims and the summaries using the timeline here. And for each summary, we will ground it into the claims. So here, we have the references, and then we have the claim sentences that we extracted from the original article, and we also show the original article here. So when we try to generate the summary for each question, we are able to provide the sources, and then human can justify whether this part of generation is trustworthy or not. I think this kind of summarization is very different from the state-of-the-art GPT-4 generated summary. So we actually use a similar setting that GPT-4 is able to collect the data, retrieve the data using the new Bing search interface. So here we ask the same question, the equivalent question, generate a report to describe the situation of Ukrainian crisis between October 16 and October 30th. And the generated report is very short and it's unstructured. Another thing is that a lot of events will not be covered in this kind of generation, and the events mentioned in this news article is not strictly located in the time period that we want to ask. And also because our generation is from multiple sources, so we are able to provide the claims from different kinds of claimers, and this will provide the multi-view summary. But this kind of summary from GPT-4 is only from the news article that A trusted from, so it's not trustworthy, and it's not reflecting the multiple views for this Ukraine crisis. We are able to collect the opinions from Chinese news agencies, but this kind of GPT-4 interface is not able to do it. As a result, this kind of facts-based generation and also the fact discovery techniques will enable us to better understand the knowledge, especially in the multimodal setting. And it involves three kinds of techniques. Firstly, we want to help the model to better reading large-scale data. And this kind of reading ability focus on understanding the complex situation by using the structural cross-model transfer to understand the multimodal structured knowledge. And then, based on these discovered facts, we want to summarize the common patterns from historical data to discover how events is evolving. So we can build the event graph to connect the dots, and then we can predict what will happen next. And after that, we also need to use these facts to do grounded generation so that we can control the generation to be truthful. And along this research direction, our research contribution is trying to promote this event-centric multimodal knowledge acquisition techniques. And these techniques will involve two kinds of abilities that we mentioned earlier, that we want to extract the event knowledge from different modalities, and we also want to track events along the timeline. And finally, we want to use this knowledge to do a more truthful generation. So for the first reading ability, we will introduce how we can tackle the challenge about multimodal semantic structure discovery. The good thing is that there are some existing research trying to discover the semantic structures from the vision data itself. For example, situation recognition tasks can recognize the images as some verbs, and then it can generate a table to describe the participants involved in these verbs. But this kind of generation is in a supervised setting, so it manually annotated around 500 verbs, and then the prediction can only be limited to these 500 verbs and cannot handle some emerging types like the vaccination. And another thing is this kind of generation is vision-only data, so it cannot handle if we have text news in parallel, whether we could build the connections between the vision data and the text data. As a result, we want to tackle this kind of two challenges, and we want to do the event extraction in the unsupervised and also in the multimodal setting. So we didn't try to rely on the annotated data, but we want to borrow some supervision signal from other modalities to understand the vision data. And here we use the language as the rich resources and to use the signal from language to help the vision understanding. But it's not a simple transfer because our understanding is about the structured knowledge. So when we do the transfer, we actually do a structured transfer. For example, from the text side, given the caption, we could run some existing text information extraction tools to discover a table, to discover this structure from the caption. Like here, we can discover the event is about the carrying event, and we can also discover the participants, like the agent is the protesters, the target is the injured man, and the instrument is the stretcher. And then we can introduce this structure as a pseudo label for the image side. So this kind of structure will provide the positive labels, but we also want to generate some negative labels to help the model to learn the semantics of the events. So we manipulate this kind of structure. For example, for the event type, we can sample the hardest ambiguous event type that is related to carrying. For example, we can use the confusion matrix of the existing event detection model. So we could figure out like arrest is the type that is ambiguous to the carrying event, because arrest and the carrying are both describing some people surrounding something in the middle. So they have similar visual patterns, so they are ambiguous, and then we can sample the arrest as the negative labels for this carrying event.
Manling, you're on mute.
You are just mute your mic.
Oh, sorry. So, so I didn't know I was muted. So when I started to mute it, so,
I think just for a few seconds, no worries.
oh, sorry. Yeah, I didn't know why it's muted. Yeah, sorry. So, so basically, we try to manipulate the event structure to generate the negative labels. So the first manipulation is about event types, and we can sample the arrest using confusion matrix as the negative label to this carrying event. And another manipulation is about the participants. So for participants, we can manipulate the semantic roles by switching the order of these participants. And then we can use a GPT-based model to describe this kind of table into these short sentences. And these short sentences are the negative descriptions to this image. And then we could train the text encoder and image encoder using the contrastive learning loss. So we optimize the model to distinguish this positive label from the negative labels. And this is how we could get rid of the annotation, but trying to manipulate the caption using the event extraction tools from the language side to create the positive labels and negative labels for the image data. So we could do large-scale pre-training using the naturally existing image caption pairs. And next, we will talk about whether we could build connections between image and the text modality. So it's not just a single modality task, but we want to do it in a multimodal setting. Basically, we can build a graph from the text side using the event extraction tools we mentioned earlier. So we can use triangle to represent the events we discover from this sentence, and use circles to represent the participants. And also, we could detect the semantic roles of these participants. And from the image side, we want to construct a similar graph. So we use the image itself to represent the event that is happening. So it's the predicate. And then we can use some object detector like faster RCNN to detect the objects in the image. So we can use the objects as the surrounding nodes of this event nodes. So we can also build the image event graph using these methods. And our goal is to learn the alignment between the text graph and the image graph. The difficulty here is that we do not have any annotation about this alignment. So we only know this is about image caption pairs. As a result, we propose to use optimal transport to minimize the distance between the image graph and the text graph. Because they are image caption pairs, they should describe the similar events, similar semantics. So for optimal transport algorithm, we will firstly try to decide the distance between these nodes. So we use the image encoder and the text encoder we learned just now to produce the embeddings. And then we calculate the cosine similarity of these embeddings to use them as the cost matrix to decide the distance between these nodes. After that, we minimize the distance between the entire graph, entire image graph and the entire text graph. So optimal transport algorithm is very nice that we are able to solve it using a proximate solution by running the sinkhole algorithm. For example, if we want to minimize the distance between these two graphs, then we could introduce this P and Q variables here, and then we can optimize P and Q iteratively until we can get the approximate solution of this optimal transport plan T. So optimal transport algorithm provide us a way to use the unsupervised algorithm to generate the approximate solution and to solve this problem about like what is the alignment using the distance between these two graphs. So basically, we can run this optimal transport algorithm to minimize the distance between image graph and text graph, and then we can get this transport plan T. This transport plan T will be able to provide us the like probability between every node pair that they are aligned. So this kind of algorithm provides us a way to align any image with any kind of text graph. For example, for this image, it's the first time that the model is able to detect that this is the vaccination event, because earlier all the annotation do not have this kind of event type. And if we have this unsupervised training, we are able to align the image with any kind of text strings. So as long as we provide like a vocabulary that contain vaccination as part of the type, then we could try to do the alignment and then use the like vaccination that is ranked as the highest similarity score to as the predicted type. So here we can see like the model is able to predict the vaccination is the event happening in the image, and we can also try to do the alignment for the objects. So we could figure out who are the agents and who are the targets. And this is another example trying to see that the model is able to nicely detect the participants. For example, for the arrest event, the model is able to detect the person in the middle is the detainee, and the person surrounding him are the agents. And this, the third example is trying to see that the model is able to distinguish the images with similar visual patterns. For example, they are all about people are getting together, but the model is able to detect the first image is about protest and the second image is about celebration. So it's basically because like the objects involved in the events and also the maybe the environment about these events. So this is about the first technical session, and we basically try to introduce the idea that we want to discover the semantic structures of different modalities together. And then when we're trying to discover this kind of structures, we do not want to use a supervised setting. We actually want to use a self-supervision to use the language to help the learning of the vision modality. So if you have any questions here, I can take some quick questions.
Yes, we have some question coming from the chat.
I see. So I think the first question about the location, I think it's related to the example about the location of the protest. So that location is actually from the text caption, and the text caption is included in the data set. So the idea here is that we want to not only extract the information from image, but also we want to extract the location information from the caption. And for the second question related to the bounding box, so it's a very good question that we do have this kind of extension. So for each bounding box recognized using object detector, we will enlarge the bounding box by, I think, 20%. So we try to include some surrounding pixels with that bounding box. So I think that's also some common practice in other papers that's trying to include the surrounding background for objects. So we actually follow the existing work to do that. So I think for the vision event extraction and the grounding task, the major difference is we also want to discover the grounding for the participants using the semantic roles. So for example, traditional grounding is mainly about whether we could ground a person to the like image, or whether we could ground a dog to the image. But now we want to discover like who are the protesters. And also for the arrest events, we want to discover which person is the detainee and which person is the agent. So they are all about person, but they are playing different semantic roles. So this is more about like semantic structure grounding rather than just trying to ground the object information. So that's a major difference. Yeah. Yeah, these are very nice questions. Yeah, I'm really happy that like a lot of people will try to like discuss more about this topic. Yeah. So I also welcome any question later. So I think the next technical session will be more concise. So we basically want to discover the connections between multiple events, and then we can try to discover the pattern knowledge. So pattern knowledge is very important because they are repeating itself. For example, these are the pattern about making a cheesecake, and we know like we basically follow several steps. Like we want to make a crust first, and then we make the bake the fillings, and then we bake them together. And if we want to make a cheesecake that have different flavors, we will still follow the similar procedural pattern, and then we just replace the ingredient with some other ingredients. So this kind of pattern knowledge will repeat if we want to like make this cheesecake of other flavors. And this kind of pattern will also repeat in some daily life news. For example, this is about the vaccination. This is about the COVID a disease outbreak scenario. Like the first disease outbreak is about H1N1, and we can see there's infection first, and after that there's outbreak event, and after that there's quarantine event from very different countries, and a lot of places will be closed. So for another disease outbreak like the SARS disease outbreak, it follows a similar pattern, although the like time distribution is kind of different. So we can also know there's infection, there's outbreak, and we can also introduce the quarantine event, quarantine policy from very different countries. Based on this kind of pattern, we are aware that this quarantine event is very important. So like when COVID pandemic happens, we also know like maybe we need to introduce the quarantine policy and trying to help people to follow some historical like effective policies trying to prevent the spreading of the disease. So this is the goal that we try to induce this kind of graph pattern and to help people to prevent something bad happen in the future. And this kind of pattern discovery is called as the schema induction in the related work. So schema is trying to discover some pattern that describing the evolution of events. For For example, there are existing work trying to decide, like after arrest, there will be charge, plead, convict, and sentence event. But this kind of discovery is just a sequential ordering of existing events. So we can treat it as the event language model. Like after arrest, charge, and plead, we can predict the next event is the convict. But in our setting, we just mentioned like we want to build the connections of events, and this kind of connection is not just a sequence, it's actually a graph model. For example, for this event of disease outbreak, we can also build the schema pattern here. Like after the transmission, there will be people get infected, and some people will show symptoms and some people will not show symptoms, but both of them will be diagnosed and tested positive. And after that, there will be quarantine event, and there will be also treatment. And this treatment will trigger a lot of different potential results, like people maybe recover, or maybe some people cannot recover. So this will be like multi-dimensional prediction that will show there's like multi-dependency between events rather than just a sequential dependency between events. So as a result, our goal is trying to discover this kind of patterns from historical events graphs. And this historical events graph, we can automatically collect it from Wikipedia. For example, if we want to build the schema graph for disease outbreak, we can collect all the disease outbreak from Wikipedia, including H1N1, SARS, and all other diseases. And for the output, we can try to generate a graph structure like this. To do this, we use this historical event graph as the training data. And then we just train the graph generation model based on this historical event graph, try to recover this, reconstruct this historical event graph. For example, if we have this partial graph from historical events that there's diagnosed event and also treatment event, then we could ask the model to predict the next event. And if we predict it as the quarantine event, we also want to predict the participants. And then we can just use graph neural network to initialize the node vectors of these newly added nodes. And after that, we can predict the connections between these newly added nodes with the existing nodes. So this is also something very, very challenging compared to traditional graph generative model. So here we not only want to generate a node, but we also want to generate a subgraph that containing both the events and the participants. And then during this generation, we have the process to merge nodes. For example, if we predict that the quarantine target, this person should be the person who tested positive, then we need to merge this newly added person with the existing person node. To do this, we introduce the copy mechanism. So basically, we will firstly check whether we could copy the existing nodes to the current newly added nodes. If we cannot be copied, then we just create a new node from the vocabulary. For example, here we can merge the existing node by copying the existing person to the target row. And then we also try to predict the relationships between entities, and also try to predict the edges between the events. So these edges will be the temporal edges. As a result, here the temporal edge prediction, we can predict the quarantine event is related to diagnosed event, but there's not a relationship between the treatment. So this kind of graph generative model is able to train on the historical event graphs, and then we could build this kind of model as a predictive model to just generate the future nodes for any given existing graph. So this kind of prediction can be compared with the event language model we mentioned earlier, and we can see the prediction performance basically increase significantly. And this line of work is trying to promote the idea that we want to build the event knowledge graph that can show how the events are connected, and also we want to discover the pattern knowledge about this event graph. So there are some surveys coming up last year trying to follow this new direction that we introduced. And also they include my work as the foundation work for this new direction. We want to say that whether this kind of event graph will introduce some knowledge about the pattern mining, and also we can introduce this kind of common knowledge to help large models to better understand the future. So I can also take some quick questions here for the second technical session. I see there's a question related to the relationship between the system and the existing knowledge graph. So I think the basic idea is also about the level of semantics we try to express. So for my model, we basically try to extract the event-centric information, and this kind of extraction is a like dynamic streaming database extraction. So for any daily news that coming into like people's vision, maybe we are able to run the system and to build the graph, and then we could dynamically grab the important event information and try to predict future events based on this portion of the event that newly emerged. But for the existing knowledge graph, I think it's more about the facts related to entities, like it's trying to include who is the president of United States, and what is the like relationship with that person and other person. And also it's kind of static because for the streaming data and for some newly emerging scenario, it always needs human help to just generate the new pages. So I think the major difference is whether we want to focus more on the dynamic, like event-centric information, and trying to trace the evolution of the events. The motivation behind the event graph reconstruction is we want to use some self-supervision to learn a graph model. So we do not have any annotation like trying to see like after the current event graph, the next event will be something. So we do not have this kind of annotation. But if we use the historical event graph, then we can naturally have a lot of data that we can mask the some of the event nodes, and we can use the partial event graph to predict the masked event nodes. So this kind of reconstruction provides us a nice way to do the self-supervised learning of the event graph model. So that's the reason we use the reconstruction loss. Yeah, thank you for all these very good questions. So I think we can also discuss more at the end of the talk. And the third part is very short, so I think it's mainly about whether we could use this factual knowledge discovery to help a lot of applications. So there are a lot of applications we can use, and in this talk, I'll just use timeline summarization as an example. So timeline summarization is very challenging because it will need multiple news articles. It's like multi-document summarization is mainly for maybe 10 documents or less than 100 documents. But in this timeline setting, it always face around like 1,000 news articles, or like sometimes just like 5,000 news articles or something. So the input size is much larger than the multi-document summarization, this kind of formulation. And another thing is that the output is semi-structured. So we not only try to generate a short passage, but we also want to organize the summarization along the timeline. So for each key date, we want to generate a short summary. So it actually needs the model to understand the temporal dimension and to select the key dates. And the algorithm here we want to use is try to extract the event graph first, and then we do graph level compression to compress the large graph into a smaller graph, and then we can select the sentences related to this smaller subgraph and then compose them into a summary. So we didn't rely on like GPT-based model because this model cannot handle this very long document summarization. And we do not have any training data to train this large model. So we basically need to use the unsupervised methods to do the summarization. So in this setting, we actually also rely on optimal transport to do the graph-based summarization. And we have this summarization goal that we want to minimize the distance between the input graph and the summary graph because we want to minimize the information loss. So they should convey similar information, although the size is much smaller. And the constraint here is that we only keep maybe like 5% nodes in the original graph. So with this optimization goal and this constraint, we can get the approximate solution about like what kind of nodes we want to keep. And then we can use this kind of methods to concatenate all the sentences related to the small graph to generate them as the timeline. So we can see that compared to the baseline, our model is able to discover more events. So here we highlighted the events using the red color. So we can see the timeline we generated have a lot of more events compared to the baselines. And then along this research direction, we basically want to build the event graph, and then we want to discover the pattern knowledge. And this kind of graph structure can also help to do a lot of generation-based tasks, like we can do control generation, we can do the generation by grounding the content to this kind of factual graph. And we also released a lot of multimodal information extraction tools, try to give some off-the-shelf tools to the community to directly extract any kind of events from the multimodal data. And we also apply this kind of knowledge graph construction techniques to biomedical domain. So we try to extract the COVID literature knowledge graph by extracting the genes, disease, chemicals, and also try to build the connection between them. And then when we generate the report, like when we're trying to do drug repurposing, we can just search the knowledge graph that we generated to discover the relationship, the connections between any kinds of nodes. Like here, we can discover the connection between any some kind of drug and also the disease, and to see the evidence that's mentioned in the literature showing their connections. And to move to the future, we basically feel like this kind of deep semantic discovery has been researched for a long time in the text modality, but it's kind of a new topic in the vision modality, especially in the multimodal setting. So I think we just started to work on the multimodal event structure discovery and trying to build the event graph to discover the common patterns. But there are a lot of space to work on this direction. So I think this is also related to the future of information extraction. Like we not only want to extract the knowledge, but we also want to tackle the bottleneck of the current information extraction techniques. Like we do not want to limit our system to some annotation intense techniques, and also we want to make it in the open world setting that it's not limited to some existing ontology. So to move to the future, we want the model to be factual, that we can compare the information from different corpus, from different data modalities to do cross-validation. For example, if we want to correct the information, we could do the information surgery and to validate the information from different languages, modalities, and sources. And we can also do the multimodal information discovery using these techniques. So we not only just discover the information from text, but also other modalities will include like vision and robotics and sensor. So basically, we want to build this multimodal system not only just for images and videos, but also extend it to like a sensor data and medical data, like MRI data. We want to associate any pattern to the semantics. So this is basically can be simplified to the alignment between any data pattern to the semantics in the language. So we can train it as like language plus X framework. And another thing is that we want to focus on the situational understanding. So we can ground it to the like social environment to discovering the social patterns. And we can also apply it to the healthcare scenario. For example, if we want to build the knowledge graph from the knowledge related to the medical care, then we could extract the information like what is the current status of the patient, and then we can match back to the medical care documents to see what is the best solution after seeing these kind of symptoms. And we also build a lot of open source systems and demos, and we welcome any suggestions when you are using these kind of systems. And I also want to mention like this kind of work are not only done by me, but also there are a lot of students working with me. So I have worked with like summer interns in our group and also master students in our group, and also a lot of professors and also collaborators have helped me tremendously during my PhD studies. So I really appreciate the mentoring from them. So if you have any questions, you are welcome to bring them up. And also, I mentioned earlier that I have 2 to 5 PhD positions. And if you are interested in working with me, please feel free to let me know. And also, I'm happy to schedule any like short meeting trying to discuss about the application, or if you have any questions related to application, you can also feel free to let me know. Thank you. I can see whether there's any questions.
Yeah, thanks, Melly. You can check the chat box. We have some more questions.
Yeah, so I think there's a new question related to the reliability of the event graph. So I think it's a very good question, especially the like construction precision and the coverage is very important to the summarization. And we kind of feel information extraction is some techniques trying to filter out the unimportant information and only keep the important things. So I think we do see like the coverage wise, the existing techniques is actually perform well, that it's trying to just mention the information that has been frequently repeating in the corpus. So although sometimes it will miss some information, but we basically consider maybe that's a good missing information, so we can just focus on some important part. And for the accuracy of the extraction system of the knowledge graph that we built, we also see like there are some wrong extractions, but we kind of try to focus more on the like context representation. So for example, when we are doing the graph compression, for each node, when we generate the node embedding, we not only just use the single event that we extracted, but we actually use the entire sentence to include more context into that event. So this also help us to reduce the impact of the like extraction errors, because we include more context into the model. So I think there's also a long way to go, that if we want to improve the knowledge graph, the event graph quality, then the performance will be better. So in that paper, I actually show some statistics about like the how the quality of the event graph will affect the summarization quality, and the like the quality is better of the event graph, then the generation quality will be much better. So that's closely related, but I think we also tried some ways like trying to use the context to help reduce the effect of the inaccurate extraction. Yeah. Yeah, I think it's a good idea to apply this kind of event graph into criminal investigation, because we actually worked a lot on the on the military domain, because this kind of research is supported by DARPA earlier, and then we basically feel the domain is a little similar. Like they have a lot of arrest event, and they have a lot of like attack, and also for the attacking event, we actually have a lot of subtype, like different kinds of attack. And we also use some like bombing scenario, like Boston bombing, this kind of terrorist attack scenario to validate the effectiveness of our methods. And we basically feel like criminal investigation is something our method like has good performance in. So we have, I think we basically trying to see whether we could track the events, and also we have some topic about whether we could trace the status of the bomber. So like the location of the bomber, trying to do the prediction based on the location of the attacking, and the location of like if they want to make the bomb, they will involve several actions. Like they need to search the internet to learn how to make the bomb. They need to purchase the materials, and they need to assemble the bomb together. So we do have this bombing like schema pattern we released in our system, trying to help maybe police to trace back like who the bomber is, if we could use this kind of event actions. So the event graph, for the negation of the event graph, that's a very good idea. So I actually didn't try it earlier to see whether we could use this participant constraints to infer there is no event, because currently it's very hard to say, like if we didn't see the protest, then there is no protester event. If we didn't see the protester, then there is no protesting event. So I think there should be more constraint. Like if we could discover the attributes for each event. For example, we also tried some method like for the event of protest. Maybe we could discover the protest the patterns. Like there might be like some buildings related to government office, and there might be people like holding banners. So banner is some attribute closely related to protest, and maybe there will be like other attributes, and then we could use these attributes to do the negation. Like if there's no banners, maybe it's not a protest. So I think maybe attribute-wise negation will make more sense rather than the participant-wise negation. But I think it's a very good point. Yeah. Yeah, I think I answered all the questions in the chat. Yeah, please feel free to let me know if I miss any question here.
Yes, thanks, Melly, for a very informative talk today. And we have reserved lots of questions. And if you have some more questions, you can send email to Manling later.
Yeah.
And
any question here.
And so, Manling, could you please take a few minutes to pick the most interesting question, and he will reward us and we'll go for them. Yeah, we have received lots of questions, so yeah, it's really hard to make decisions. And meanwhile, we will invite the lucky audience. And so, if your name is called, kindly raise your voice to claim your prize, and we will spin the wheel up to 3 times to determine the lucky winner. And if no one claims the prize after the first 2 spins, the third one will be the winner. So could you please share the spin wheel now?
Yeah. So here is the attendance today.
It's so cool. Yeah, thank you for attending the talk.
Long we haven't seen your screen yet.
Yeah. How you see my screen?
No.
Yes.
It's good now.
Okay. So we have 3 turns, and this is the first turns. Congratulations, Nguyễn Anh Quốc. Are you still here? Nguyễn Anh Quốc, can you raise your hand? Or oh, okay.
Yeah.
Congratulations.
Okay, so congrats, Quốc Anh. So you get 200 gold from AI Center. And now mainly, have you selected the most interesting one?
So do you mean the most interesting question? Yeah, so let me see. So maybe I'll select the one like related to the reliability of the generated event graph, because I think it's related also to like what's something I want to do in the future. Like, well, if we want to increase the reliability, what we should do for the IE area and to support more applications. Yeah, thank you. Oh,
thank you, Melly, for choosing me. Okay, so thank you very much for your talk. I'm really impressed by your work, actually, and hopefully that you have inspired many of our residents to pursue these directions. And could you share the way that they can contact you again, like maybe an email, or they can go to your website in some URL so that they can contact you. So residents, if you are here, please take a screenshot if you want to save Manling's contact. Yeah, she's really open to talk to you, to maybe provide advice, as well as to suggest the opportunities that you can consider.
Now you can find mainly email on the chat box.
Yeah, so I also send my personal website here. So I think I will be a postdoc next year at Stanford. So maybe I'll have a new like Stanford email address. But yeah, I think I'll update that in my personal page as well. Yeah, thank you. I really enjoyed the discussion and the talk here. And also I really feel fascinated about this like lucky audience part. Yeah, it's really cool. Thank you.
And before the webinar ends, we would like to receive the feedback from audience to improve our webinar in the future. So Long, could you please share the feedback form? And we will reward 100 gold for the most quality feedback. So now we come to an end of the webinar, and thanks Manling again for joining us. And we hope that the audience have gained much knowledge from this webinar, and we look forward to your participation in the future. Okay, thank you and goodbye everyone.
Thank you. I really appreciate the opportunity. Thank you.
Thank you very much.
Xin chào tất cả mọi người, mình là Tuyết, là admin điều phối chương trình AI Event-Centric tại Hà Nội. Mình gia nhập cùng với SC Software AI Center từ tháng 5 năm 2021. Nhiệm vụ chính của mình tại AI Center thì chính là làm công tác hậu cần cho AI Event-Centric. Mình sẽ phối hợp cùng với các phòng ban khác thực hiện các công tác tuyển dụng, truyền thông, tổ chức các hoạt động văn hóa nội bộ và vận hành cho AI Event-Centric. Với mình thì nhiều cảm xúc lắm các bạn. Nó có cái sự bỡ ngỡ rồi hoang mang cái thời gian đầu ấy. Đấy, khi mà mình vừa mới bắt đầu chương trình được khoảng 1 tháng thôi thì bắt đầu Hồ Chí Minh này rồi Hà Nội bị lockdown và cái việc work from office, nên là chúng mình vốn dĩ đã là chưa quá là quen thân nhau ấy, xong rồi bây giờ lại chỉ có làm việc qua email và tin nhắn thôi, nên là rất là khó khăn. Đấy, nhưng mà được cái là trong cái khó nó lại ló cái khôn ấy. Đấy, trong thời điểm đấy thì chúng mình có rất là nhiều những cái hoạt động bonding online, kiểu như là hát karaoke là chơi game với nhau, nên thành ra là tuy là cái thời điểm giãn cách nhưng mà chúng mình cũng đã có rất là nhiều niềm vui cùng với nhau. Và với mình thì cái sự vỡ òa đến lớn nhất đó là khi các bạn resident có những cái kết quả đầu tiên về paper và các offer về PhD. Và thì tính đến thời điểm bây giờ thì các bạn resident cũng đã có các paper và các hội nghị top đầu tới về AI và học máy như là ICML, UX, WACV, CDPR. Và tháng 10 vừa qua thì anh Minh Tân và mentor của bạn Minh Tâm đã gửi email thông báo đến cho mọi người biết là bạn đã nhận được offer của PhD ở trường Rise. Còn email cảm ơn mình, anh Dũng và đội ngũ support của AI Event-Centric nữa. Nên là chúng mình là vô cùng là vui và xúc động khi mà được đồng hành cùng các bạn ấy đạt đến những cái thành tựu đầu tiên. Mỗi bạn AI Resident thì đều có mang một màu sắc riêng. Với cá nhân mình thì mình rất là ấn tượng với các bạn nữ trong chương trình. Ở batch 1 thì có bạn Minh Tâm, bạn Mỹ Học Phương Trang. Batch 2 thì có bạn Đậu Thị Vân Anh, Võ Thục Khánh Huyền. Batch 3 thì có bạn Lê Minh Phương. Thì tất cả các bạn